You hold a leather wallet, a belt, or a car seat. Smooth surface, consistent texture, expensive finish. Now imagine that some of that luxury material started as something most people throw away. Cow horn. Not the hide, the actual horn. Hard, rigid, opaque. How does a factory take that and turn it into something that looks and feels like premium leather? That is what we are going to explain today. Before we continue, leave in the comments your name and what city you are watching from. We love knowing where our audience is located. The process is more mechanical than you might expect, and the physics behind it is surprisingly simple once you see the steps. Cow horn is made of keratin, the same protein in human hair and nails. But unlike hair, horn keratin is densely packed, almost like compressed layers of microscopic fibers, all aligned in one direction. That density is what makes horn hard. To turn it into something flexible like leather, the factory needs to do one thing: break that alignment without destroying the keratin itself. The first step happens in a machine called a horn press. Workers feed cleaned horn pieces, usually the outer sheath separated from the bone core, into a chamber. The chamber heats the horn to around 150 degrees Celsius, just below the point where keratin begins to chemically degrade. At that temperature, the protein chains inside the keratin soften. They do not melt like plastic, they just lose their rigidity. While the horn is soft, hydraulic pistons apply pressure from above and below, around 200 tons per square meter. The pressure flattens the horn into thin sheets, usually 2 to 3 millimeters thick. The keratin fibers, which were stacked vertically in the original horn shape, now get forced into a horizontal plane. That is what gives the flattened horn its leather-like flexibility. Once flattened, the sheets cool and harden again, but now in the new shape. The cooling happens in 2 stages. First, the press opens, and the sheet drops onto a metal conveyor belt. The belt is kept at room temperature, around 20 degrees Celsius, which pulls heat out of the sheet at a controlled rate. If the sheet cools too fast, internal stresses form, and the material becomes brittle. If it cools too slowly, the keratin fibers start to realign, and the sheet loses flexibility. The optimal cooling time is about 8 minutes. During this window, the sheet passes under a series of rollers that apply light pressure to keep it flat. Without this step, the edges would curl upward as the material contracts. Here is the part most people do not know. The flattened horn at this stage is still translucent, not opaque like leather. You can hold it up to light and see through it, almost like a thick sheet of amber. To make it look like leather, factories apply a surface treatment. They coat the sheet with a mixture of natural waxes, oils, and pigments. The wax fills microscopic pores on the surface, the oil adds suppleness, and the pigment gives it the brown, black, or tan color you associate with leather. Some factories also press a texture pattern into the surface using heated rollers with embossed designs. That texture mimics the grain pattern of cowhide. The embossing rollers are heated to about 80 degrees Celsius, warm enough to soften the wax layer, but not hot enough to affect the keratin underneath. The pattern depth is typically 0.2 millimeters, just enough to catch light and create visual texture without weakening the sheet. Each roller can emboss up to 15 square meters per hour. If you compare a piece of horn leather to real cowhide under magnification, you can tell the difference. Real leather has irregular pores where hair follicles used to be. Horn leather has a more uniform surface because the texture was stamped, not grown. But to the naked eye and to the touch, they are nearly identical. Horn leather even develops a patina over time, just like animal hide, because the wax and oil layer oxidizes with exposure to air and skin oils. Now, why go through this process instead of just using regular leather? 3 reasons. First, horn is a byproduct. Slaughterhouses already produce it in large quantities, and most of it would otherwise be discarded or ground into fertilizer. Using it for leather adds value to waste. Second, horn leather is more water-resistant than traditional leather. The keratin structure, even when flattened, does not absorb moisture the way collagen-based leather does. A wallet made from horn leather can get wet and dry out without stiffening or cracking. You can test this by placing a drop of water on horn leather and another on cowhide. The water beads up on horn leather and sits on the surface for several minutes. On cowhide, it soaks in within 30 seconds. That difference comes from the fact that keratin has fewer hydrophilic sites than collagen. Water molecules have nowhere to bond, so they stay on the surface. Third, it is cheaper. Processing horn into leather costs less than raising cattle specifically for hides, tanning those hides, and finishing them. A square meter of horn leather sells for about 40% less than equivalent quality cowhide in bulk markets. But there is a trade-off. Horn leather is less durable under repeated bending. Collagen fibers in real leather can stretch and return to shape thousands of times. Keratin fibers, once flattened, tend to fracture after fewer cycles. That is why you see horn leather more often in wallets, watch straps, and decorative panels, products that do not flex constantly, and less often in shoes or jackets. Some factories try to improve durability by laminating the horn sheet onto a fabric backing, usually cotton or polyester. The fabric takes the mechanical stress and the horn provides the surface aesthetic. That hybrid material shows up in car interiors, especially in luxury electric vehicles where manufacturers want novel materials that signal sustainability. The lamination process uses a polyurethane adhesive applied at 60 degrees Celsius. The adhesive bonds to both the keratin and the fabric without soaking through either layer. After lamination, the hybrid sheet is 3 times more resistant to tearing than horn leather alone. One factory in Southeast Asia produces about 5,000 square meters of horn leather per month. The process from raw horn to finished sheet takes roughly 6 hours per batch. The factory runs 3 shifts, processing horn from local slaughterhouses that supply beef to regional markets. The horns arrive in bulk, already cleaned and separated from the skull. Workers sort them by size because smaller horns yield thinner sheets and larger horns yield thicker ones. After sorting, the horns go into the press. After flattening, the sheets move to a coating line where robotic arms apply the wax oil pigment mixture in 3 passes. First pass is pigment for color, second pass is wax for texture, third pass is oil for flexibility. Each pass involves a drying stage under infrared lamps. Total coating time is about 90 minutes per batch. After coating, quality control inspectors check for air bubbles, cracks, or uneven color. Defective sheets get sent back to be reprocessed. The accepted sheets get cut into standard sizes, rolled, and shipped to manufacturers who turn them into finished products. The waste from cutting, about 15% of each sheet, gets collected and ground into powder. That powder is sold to fertilizer companies or used as filler in composite materials. Nothing from the horn goes unused. Here is another detail that rarely gets mentioned. The smell. Raw horn, when heated, releases sulfur compounds because keratin contains cysteine, an amino acid with a sulfur atom. The smell is similar to burning hair, sharp and unpleasant. Factories deal with this by installing ventilation systems that pull air through activated carbon filters. The filters trap the sulfur compounds before the air exits the building. Some factories also add a small amount of vanilla extract to the coating mixture. The vanilla does not change the material properties, but it masks any residual smell in the finished product. If you have ever noticed a faint, sweet scent in a leather accessory, that might be why. So when you see a product labeled as sustainable leather or eco-leather, check the material composition. If it says horn keratin or bovine keratin, you now know exactly what it is and how it was made. It is not a synthetic plastic trying to imitate leather. It is an organic material restructured through heat and pressure, coated to look like hide. The chemistry is simple, the machinery is straightforward, And the result is functional. No magic, no hidden process, just applied physics and material science. If you want to see more explanations like this, subscribe to the channel so you do not miss the next one. And go ahead, leave another comment with your city. We are building a map of where everyone is watching from, and we would love to add your location to it.